Science with Folly.
Kia ora, welcome to Science with Folly. Today, we're going to be learning about covalent networks. So covalent network substances are large networks of non-metal atoms bonded together by covalent bonds. And there's three main types of covalent network substances that you've got to know about. So let's start with looking at one-dimensional covalent networks. These are made up of linear chains of non-metal atoms held together by covalent bonds, and neighboring chains are held together by weak intermolecular forces. For example, here's polythene. Polythene is made up of big long chains of carbon and hydrogen atoms bonded together. Here's an example of polythene, black polythene, like this plastic bag. Polythene, as you know, is a solid in this case. But if I melted that plastic bag, would I have to add a lot of heat energy? No. So the properties of one-dimensional covalent networks are they have a low melting point. Ask yourself why. They're insulators, yet again, why? And they're flexible. Think about those three answers, and it's related to their bonding and structure. Second are two-dimensional covalent networks, and these consist of layers held together by weak intermolecular forces. And another key point about these is that these substances have delocalized electrons. One example is graphite, like in this pencil. Can you see it? Yeah, bit of graphite there. As you know, graphite conducts electricity. The properties of two-dimensional covalent networks are they have a high melting point, they conduct electricity. Why is that? They're soft and slippery, and they're insoluble. And if you look at this diagram here, you can see carbon would normally have 4 bonds, but in this case, each carbon atom has only got 3, and therefore that fourth electron is free to move around inside the structure and conduct electricity. And lastly, we've got three-dimensional covalent networks, and these consist of a whole lot of atoms covalently bonded in a three-dimensional lattice structure. For example, diamond. Sorry, I don't have a diamond on me. But they go in all directions, but they're bonded by covalent bonds, which means their properties are very hard, they're insoluble, they're insulators, they're not going to conduct electricity, and they have a high melting point. And you should be able to explain their properties by their structure. That's it for me today. Good luck with your learning. Ka kite anō.
Science with Folly.